So that doesn't mean you can drink it because you need to quit that shit. Oh wow. Then that means you're continuing. Good. That's gonna be in front of you and so so we're gonna start. Actually, we're gonna start calculus today, which is we haven't started calculus yet. So we're gonna start with the limits. Now let me ask you, on your previous teacher, how many people have introduced limits? Okay. Yeah. Okay, so let's start with Claire. Can you tell me anything about limits? Okay. Anybody else? Yes. Yes.
Restrictions for the ground. Boundaries.
Could be. Okay. Anybody else? Astrid? Ashton, sorry. Not Astrid. What did I call you Astrid? Astrid's over there. Ashton. The way to run out and behavior. Okay, good. I like that. See, Ashton was gonna not take my class. I'll be upset. Not taking my class. That's a great answer. Anything else? Elsa?
So just how far the graph goes in all directions with the y-values and x-values.
Okay, that's kind of like an behavior situation. Yes.
If I remember correctly, what it is how many times a graph was thinking curves and whether or not it goes up or down.
Yeah, you're talking about ambient behavior as well. Yes. Anybody else like to add? Okay, so limits. I might give you an analogy. So let's just say, see who I want to pick. Who I want to pick? Want to be a volunteer? So you can stay on this side. So let's just imagine that there is a black hole right here. It's like a tiny dot, like right here. It's just so small that we need to go find out this location of black hole.
What we think dark matter is, well, one of the three things being tiny little black hole, the size of an atom with the mass of an asteroid.
Yep. So right now, our goal is just find out this black hole location is. I don't know. When I was little, I grew up with Dragon Ball Z. Anybody watch Dragon Ball Z?
I know.
Yeah, but not a new one like that. But the old one when he was a little kid, like when you have.
Oh, the original Jump Dragon Ball.
Yeah, like they have a radar detector.
Yeah, I'm on the second season of that.
Okay, looking for the Dragon Ball. So what the idea is, we are looking for the black hole instead of Dragon Ball. But the thing is, can you stand on top of a black hole?
No.
No, that's a bad idea. However, this is the way I wish to die. Because any other way to die would be not cool. I think that'd be a cool way to die. So it's gonna be very short-term pain. It'll be and you don't hear the scream.
Well, actually, the whole point of it would be permanent. It kind of slow down so much that you would be eternity in an instant.
Don't you die very fast?
No, you die so slow that you would never. You technically become immortal, locked in the.
But the gravity is gonna pull you basically to pieces.
Yes, but it'd be impossible to technically tell what would happen because the time spatial distortion and the whole life's not working.
So I don't know. Apparently, I don't know anything about black hole. But still, I'll be like very proud of myself if I die that way. It doesn't matter how painful I will do it. So if we try to look for the location of this black hole. So what we can do is we can say, hey, let's take a GPS and let's go approach it very, very slowly, but from both directions, not only from one direction, from both ends. You're coming slowly. So what we're gonna do is Shaden's gonna take one step forward, and I'm gonna take you a step. Take a small step. Okay, so I'm gonna take a small step right here. So we're gonna approach and we're gonna count out. We're gonna look at our GPS, see what is right. How do we get closer and closer? So we're gonna take another steps, and we say, okay, it's somewhere here. Well, it's good. Like we're gonna read it already. We say, hey, we haven't died yet. That means we're okay, right? So we're gonna take a step closer, and we're gonna get a step closer. So hopefully we can find out a point that we could be interested in. Because right now we can say, well, it's between these two spaces. Well, let's just say here. We say it's right there, but we can take another step. So then we can get closer. Let's take a half step. Have you were little, like, do you have siblings?
Yeah.
Like, your siblings come up to you, so I'm not touching you, I'm not touching you, I'm not touching you, I'm not touching you. Did Michael ever do that to you? Michael Remington?
No,
No,
he just
I
runs
didn't.
straight in.
I did it.
You did it. You're the annoying sister.
Yeah.
Just like, I'm not touching you until like you get mad at you, right? So the idea is you want to get close to them, but without touching them. Okay, but I don't really want to kiss Shaden because it's not my type. I don't like anything. Shaden, don't say anything, bro. What is wrong with you? So, the idea is we're gonna keep on taking close steps, and until we says, okay, well, we are almost at the edge of black hole, but we can say safe determine the black hole is right here, but it has coming from both ends. You cannot just come in from one end. Imagine if I just coming from one end, let's just say without Shaden existing, I can only come, but even though I know the black hole, but I don't know how big the black hole is, right? Because I don't know what it is, and we don't know what is the center of this black hole. If I want to find the center of the black hole, I kind of need it both and keep on reach closer. So thank you. So that's the idea of this. Then that's limits. Limit you can help you approach a value that mathematically that usually before not able to approach. Now, why do we need limits? The limits guidance to go into the next thing. So we get calculus right here. So we have calculus, but limit is before calculus. It's actually pre-calculus. Now, when you go to calculus, we're going to go to two different topics. At least the big part is going to be derivative. And the next part is going to be an antiderivative, or also known as integral. Okay, so our whole course throughout the year, we're going to go through limits, which is we only spend a week, but we're going to spend more time about derivative, antiderivative. But without limits, we have a hard time to get there. Does that make sense? Okay. Now, that's the start with things. Second, what would the question look like? Well, the question will look like this. So f of x is equal to x cubed minus 1 over x minus 1. Now, does anybody know what this graph look like? So take a wild guess, right? Copy. Do you guys know what a graph look like?
Notably scratchy most of the time.
It's parabola. Okay, could be.
Yes, I think it might be.
Vertical asymptotic one, possibly. I like that thinking there, but I don't. So I'm glad that you guys start suggesting stuff, because a lot of you guys are. I talked about last period. There's only like 2 people kind of raise a hand, or 3 people. It's also because second period. a lot of time, like you get so afraid to be wrong. I'm not looking for the right answer. I'm looking for your idea how much you know. Now, if you're afraid to show me that what you know, then that's bad, right? But don't be afraid of being wrong. Long as you fix it, right? You cannot be like, I'm wrong and then double down on I'm wrong. Earth is flat and guarantee the Earth is flat. And that's stupid, right? If somebody, you say Earth is flat, it's not a big deal. But if somebody prove to you that Earth is not flat, then you have to say, okay, well, Earth is no longer flat. So that's a way you kind of think about things. Now, how are you gonna think about this? What does a graph look like? Does anybody knows one or two say out loud? Yes.
Vertical asymptote at 1.
Vertical asymptote at 1. Good. What else? Anybody else? Again, no, I don't call some other people. Yes, Shaylin. A parabola? Okay, it could be a parabola. Okay. Anybody else? A bit?
It would have like two different lines.
Two different lines. Okay. Anybody else? I already calling you. I need to call other people. Elsa?
0 at +1 63.
0 at +1. Okay, I see what you're saying. Yep, that's a strong 1 points. Anybody else? Lucas?
Start in positive infinity, and then it would go through the x-axis towards negative infinity.
Okay. All right. Tanya?
It would, left and right side be going in opposite directions.
Okay. All right. So there are a few things that's good for you guys. How about and there's a few things that need to be changed. But that's okay. Everybody is actually good. Prakash, do you have anything? What's his name? The Indian kid. You. Kushan. I don't know why I call you Prakash. Kushan. Kushan, yes. No, nothing to add. Claire, do you have anything to add? No. Lynn? You have nothing. That's a problem. You gotta come up with something. It doesn't matter right or wrong. Okay. So here we are gonna show you what a graph look like. But more importantly, we want to interested about what happened when limits as x approach to 1 of x cubed minus 1 over x minus 1. First of all, do you guys know how to find domain of this function? Domain. How do I find domain of this function? Safa was able to tell me what the domain of this function last period. I don't know. Anybody can tell me the domain of this function. So what is a domain? Question mark. What will be a domain? Nobody can tell me domain of the function. Yes, Lucas? Or real number? Is that what you're saying?
Yeah.
Okay. Andrew?
Negative infinity to 1, then 1 to infinity.
Good job, Andrew. You finally belong to you stay in this class. Just because I answer, I'm gonna keep you. I won't kick you out anymore. Okay, so the denominator cannot equal to 0. If denominator ever equal to 0, so x cannot equal to 1. So the negative infinity to 1, union from 1 to infinity. Very, very good job. That's a domain. Okay. Now, why did I say limit x approach to 1? Huh. That's interesting, right? So some people say it's vertical asymptote, and some people says whatever other things. So what was the graph? We says we want to is x cubed
X cubed minus 1 over x minus 1.
over x minus 1. Okay, over x minus 1. It looked like a parabola. You're like, wait, how does it look like a parabola? But we're not going to talk about why does it look like a parabola. We're going to talk about, hey, We're more interested what happened in when x approached to 1. So I want you guys to pay attention. So anything like this output here, do you see anything different? No, right? So let's see from here. Do you see anything different? No? Are you sure? There is the black hole that we were talking about, right?
You can factor, yeah. One.
Okay, so this is the thing that we were talking about last year. We talked about this as a whole. But again, what we're gonna do is we're gonna approach a few different approach. For math, make sure Ian pay attention. I need you always eyes on the boards, not on your computer over there or on your iPad over there or whatever is on. So the first approach is should be. So we're gonna talk about mathematical approach. First approach should be numerical. Numerically. So you should approach numerically. Plug in a number. Second approach we should do is graphically. The third one seems to be the most popular one is algebraically. Algebraically. I don't know how to spell algebraically, but whatever. Fourth, analytical. So every time we look at math, we always think about what happened if a number approaching there. You can use digital thing to help you. Second thing is that you can look at the graphing approach. Look at a graph, see what it tells you. Or think about a graph, what it tells you. Third, algebraically. Can you work out algebraically? We're going to talk about that later. But right now, the last one is analytically. Not a lot of people can get there. So I would say if you score a 4 to 5, you can approach the first 3 things. Very low 5, but not a high 5. So if you really want to get like those people can reach like 90 out of 108 or 99 108 or 108 out of 108, those are people can think analytically. Analytically is so hard to think about. It's a combination of 1, 2, and 3, and depends on each cases using what situations. And they not only can solve the problem, they can solve the problem with the most efficient way. And this is your final goal. Your goal is to be able to solve a problem, not work out a lot of algebra, just think about what a graph look like. So for example, yesterday I gave out e to the 10 of x for my BC calculus when limit x approached 5/2. A lot of people cannot think of that. But some people can think they can solve the problem analytically. So this is a foolproof approach. And this is also known as a math. In the textbook, we call it rules of 4. Not that important. I will just a name, so it doesn't really matter. It's rule of 4. So when you think about math, you should think about numerically, graphically, algebraically, analytically. When your conversation talk to each other, you should think about, well, did I think about all this approach yet? And that's how you do well. In terms of everything else. Now, when you go with the things, you say, okay, well, let's do it numerically first. So what we're going to do is we're not going to use other things. We're going to use Desmos. So you guys can get your phone out. I don't really care. Okay, your computer out. Doesn't really matter. I love using Desmos because a lot of you guys need to understand Desmos is going to be something that you're going to be used a lot in terms of SAT. And if you don't learn how to use it, learn how to use it now. Another thing I want you to do is also get a TI-84CE. Hopefully you guys already grabbed a calculator. I have one to sell if you want it. It's brand new. So it's much cheaper than you can buy at Walmart. It's just the box is open. So TI-84C is something that I use a lot, but only toward the second semester, pretty much a third and fourth night week. If you cannot afford a calculator, you can get it from library. They will give you TI Inspire. I don't know how to teach that one. I'm gonna be the first one to tell you. Some people are very good on digital stuff. They can figure out right away, but it's not me. I like the old-fashioned stuff like this. Even though this one is worth like $120 if you buy it too. But usually you can buy used. You don't have to buy it new. Okay, so the question about this, then we're gonna approach numerically. Which number are we trying to approach? 1. So what happens if I plug in 1 in here? If I plug in 1 here, what am I gonna get? 1 minus 1, 1 minus 1. It's not 0, it's a 0 over 0. Now this, I want you to know this is another keyword. It's called indeterminate. It's not undefined. 0 over 0 is indeterminate. It's not knowing what the value is. We can get a value that's very close to it. I know it's not defined according to decimals, but we still can get roughly, if we get really close to it from both sides, it's going to get a value. So how do we approach from both sides? We can go into here, click on the wheel, and this wheel is going to come out a table, and you can actually click into it. And I'm going to click on the value of 0. What happens if I plug in? What happens if I plug in 1? It's undefined, right? So how do I reach 1 from the left side? What would be the value you want to get close to it? What's a value that's close to 1 but it's not 1? 0.9. Okay, so we're gonna approach 0.9. So that's gonna be 2.71. Do you see that 2.71? They give you output immediately, which is really nice. Go into here, and that's approach to 0.99. We just approach 10 times closer, right? And also, this is what you do to your brother. I'm not touching you. I'm not touching you. I'm not touching you, right? So until he smack you, and this is what the fight happened. 999, right? Click on the wheel on the top. This on the top. There's a wheel right here, and they will show you that table. Click on the table, and also you're gonna approach. That's a 1.001, 1.01, and 1.01, 1.1. So do you see that I plug in all those output values? And the two finally is like me and Shannon's walking, get closer and closer to each other, and to find out where the location this hole is. So we can safely assume if I approach from the left, 1 from the left, it's going to be 0.99, 0.999, 0.99999. It's going to be 2.997, right? Each digit I increase, the more the digit, getting closer. Long as I don't get to 3, I'm okay. So we can safely assume if it's 1, it's probably more likely to be 3 rather than any other number. But you have to reach from the both ends. That's the rule. The rule says you have to come in from the both ends. Now, there's something called one-side limits as well, but usually we're not going to get there. Questions? Now, I want you to tell me this. What happened x approach 0? Using your decimals calculator, x plus 1 minus 1. When limit x approaches 0. Now, also, hold on a second. Let me talk about graphical approach. If I look at the graph, right? I look at the graph, I see my output is more, it's probably going to be 3. Because I see this going toward 3. I can see it graphically as well. Okay. So now I want you to do this question. What happened when limit approach 0 of x over x plus 1 minus 1? learning how to use Desmos because Desmos is going to be allowed in SAT. Like crazy things about Desmos is like there's so many shortcuts to do things. The best thing in Desmos is a slider. We're gonna teach how to use slider. I'm gonna teach how to use that. TI Inspire doesn't have a slider, so it's actually more functional than TI Inspire. So it doesn't mean you get a functional calculator is gonna do well on your SAT. What'd you guys get? Lucas?
Close to 2.
Close to 2? How many guys cannot get that? The answer is close to 2. Do you see it? Yes? So what do you approach? From the left side, I would do negative 0.1, negative 0.001, negative 0.0001, negative 0.00001. And from the positive side, it could be 0.1, 0.01, 0.001. If you approach that, it's going to eventually equal to a certain value, and that value in this case is 2. We're not going to talk about how do we approach it algebraically yet. So if algebraically, what we're going to do is we're going to look at here. Today, we're not going to talk about algebraically. We're just going to talk about numerically, how do we approach it. So hopefully you got this. What you guys need to try is x over square root x plus 1 minus 1, right? Like this. And let me unhighlight all those points. So that therefore, hey, the graph stopped right here. Why is that? Why do they stop right there? Why do they stop right there at negative 1? Yes, Fabian?
You can't have the square root of a negative number.
Good job. Very awesome. You cannot square root a negative number. That's also another way to find domain. So let's look at this question. If I want to find domain of this question, find domain is basically you want to look at the square root. So x plus 1 has to be greater than 0. And x or greater than or equal to 0. So x had to greater than 0, 1, a negative 1, sorry. Right? So that is basically is a number line from negative 1. It's going this way, right? But what else? The denominator cannot equal to 0. Because denominator equal to 0 is undefined. So square root x plus 1 is equal to 1. Square both sides, x plus 1 equal to 1. X cannot equal to 0. So therefore, is at 0, this is going to be a hole. So your domain is going to be negative 1 to 0, union from 1 to infinity. So there was 2 things that you need to look for domain. One is the radicand has to be greater than 0. Second reason is a denominator cannot equal to 0. Set denominator cannot equal to 0, you're going to find a domain of the functions. Very good job, Fabian, right? Job. But the thing is, what happened when I approach 0? That we're just using that. We're going to plug in. We're going to build a table here. And we're going to plug in. How do we approach 0? Well, 0.1. This is from the positive side, by the way. I can do like this. So it's obviously it's approaching 2, but we're going to do it from the other side. Negative 0.00001, right? Negative 0.0001, negative 0.001, negative 0.01. So obviously from both ends they are approaching 2. is approaching 2 from 2 different directions. And we can say safe to assume, so when x approaches 0, it's going to be 2. So numerically, I can say that's equal to 2 because they are approaching 2. Am I going too fast? Okay. Next one. I want to ask you, how many of you guys know what a graph of this one look like? Now, you cannot use a calculator here, so don't use Desmos. Desmos not going to help you. I want you to think on your own. The reason why I wanted to challenge you to think on your own is I'm challenging you to think in that perspective analytically. What does analytically mean, right? So absolute value x over x, what would be that graph look like? Now, if I didn't give you a graphing calculator, can you figure out what a graph look like? Emerson first.
There would be no negative numbers.
Okay. Noreen?
I was gonna say it can only be positive.
Okay. Anybody else?
I have no idea.
Krish?
It's gonna be like a V on the.
Okay. Ian?
It's going to be -1 through all the negative things. Then it's going to switch to +1 for all the positive.
Okay. Anybody else? A bit? Do you have anything else to add?
It could be y equals negative 0, which means y equals 1.
Nathan? No. Elsa? No. Lucas? No. Claire? Okay. This is the part like I'm gonna challenge you. Even you don't know, you gotta try it. Is to break the thinking and thinking more analytically. Now the only person who got it correct is Ian. Now the problem with Ian is this. He doesn't know how to do things algebraically. But his analytical thinking skill is way above the chart. Way above the chart. And so the problem is algebraically now, Ian, that's what you need to improve. And graphically you have to improve. But so that's why you need to work on your algebra skill. But you have a potential to get a 5 really easily, but you have to work on your algebra skill. If you don't have it, then you cannot get a 2. But you have to break that. So, but all other people, they think why he thinks like that, right? So look at this graph. Absolute value x over x. You guys have never seen this graph before, right? For the first time. But nobody, I didn't show Ian last year. How did Ian come up with that? That's the thinking that you have to learn how to think of what happened. Okay, so I'm going to show you how to think. Algebraically, how do we think? Also, not only that, we're going to talk about in a second, we're going to talk about other things. We're going to try it for the first time algebraically, but this algebra is something else I need to explain to you. When limits x when you have absolute value x graph, that's look like, so there was a definition of absolute value. Very, very important concept. It's not in the calculus, but it's an algebra concept. The absolute value x can break to 2 functions, and it's called piecewise function. And basically, there's a positive version of this, so it's going to be x when x is greater than 0. This is called restrictions. And negative x when x is less than 0. And one of them is greater than or equal to is fine. So what happened is you have a graph here. And the graph is gonna have a red line from here to here. And you're gonna have a blue line from here to here. They're two separate functions. This function is y equal to x. This function is the blue function is y equal to negative x. It depends on restriction. Restriction start at 0, it's going to look like this. Start at negative, it's going to look like this. Any question about this part? No. Okay. So then, also one more thing I want to talk about is this. There is I'm not highlight this absolute value x, right? There was another function look exactly absolute value x. Can you think of the function look like exactly absolute value function? Except it's not piecewise. That's really hard to think about. X squared graph, does that look like absolute value function? No, right? A little, yes. But how do I make an x squared graph look like absolute value function? Yes.
You make the number on the top. No.
So imagine this, right? You say square root x squared.
Right, because squaring something always makes it positive, and you're square rooting it, which denies the squaring, but keeps the positivity. Right.
So yes, square root x squared is gonna be same as absolute value x. Now, one more thing I want to talk about. What happens if you have a x minus 2 like this? How do I break this? Well, what does x minus 2 graph look like? What's the x minus 2 graph look like? Shifted right or left? Right. Don't tell me left, please. It's gonna be right. And this one's gonna be the x minus 2 when x is greater than 2. The restrictions also shifted. Okay? And this way it's gonna be x minus 2 when x is less than 2. Okay. So this one is gonna have this. So two different functions. Remember, it's negative parenthesis. So it's gonna be negative parenthesis of that. So I here it's gonna be here. 2 is going to be something like from here to here. This is going to be x minus 2. Is that okay? From here to here is going to be negative of x minus 2. Make sure, if you want to do algebraically, think about there are two p's. It's called piecewise function. Now, I'm going to go back and look at this function. Not only I'm going to look at this function, I want to say f of x equal to absolute value x over x. So what we're going to do is we're going to write that in piecewise function. How do we write that? In piecewise function, when x is greater than 0, it's going to be using the positive side of absolute value function, which is this. And when x is less than 0, it's going to be negative x over x. Does that make sense? That lead to that this is a function is going to be 1 when x is greater than 0, negative 1 when x is less than 0. It's a horizontal line, and that's what your graph is going to look like this. Does that make sense? Now here's the thing. My next question is what happens when limit is x approach to 0? When limit x approach 0 in this particular case, is what? You guys watch the movie Mean Girl? No. Yes. William's like, yes. I watch Mean Girl. Huh?
I didn't do it for AP.
Really? This is thing says what? What is the answer for this one? Yes.
Is it that it doesn't exist?
Yes. You remember from the movie, right? Okay. Lemon does not exist. Why it does not exist? Because imagine that this is Shaden from this side, right? And this is Mr. Yu from this side. We walk into this. Do I walk into this? Lemon does not exist because we cannot conclude to one point. If we cannot conclude to one point, lemon does not exist. So I'm going to talk about which three situation lemon does not exist. So three situation, lemon does not exist. First situation is when limits x approach to a from the left of f of x does not equal to limits x approach a from the right of f of x. In this case, we got 1 and -1. 1 does not equal to -1, therefore limit does not exist. Second situation, which is this one looks like f of x equal to absolute value x over x. Look like this, right? Limit x approaches 0 from the left, it's going to be -1. 0 x approaches right, it's going to be +1. So limit does not exist. So we're going to talk about second situation, limit does not exist. Now this situation is called unbounded behavior. It's called unbounded behavior. How much time I have?
Minute.
That's it? Third situation. Now unbounded behavior is more like f of x equal to 1 over x squared. So limits as x approach to 0 here, the graph is going to look like something like this. It's like a volcano. It's like asymptote. Like asymptotes looks like this. Like normal asymptote looks like this. 1 over x looks like this. Now the reason why it looks like this because you can never be negative anymore. So all the negative regions will become positive. And you still have 0 still an issue. So that looks like a volcano graph. Okay, so that is going to give you a limit x approach 0 here. So in this case, that is going to be does not exist. Now some people can argue, even though it does not exist, some people can argue that its limit x approach 0 is equal of 1 over x squared is infinity rather than does not exist. Now that's debatable. There was two part of mathematician, they debate each other. So they come to a conclusion. If this ever show a multiple choice question, those two answers will not coexist with each other. So it will not be infinity and does not exist. It will either be infinity is one of the choice, does not exist is one of the choice. Both choices are not going to present it. So there was a debate about this still these days. So right now people says, either you can put does not exist, or either you can put infinity in this case, because they both cycle into infinity if you reach from the both sides. Last one, it's going to be this one. Now, we're not going to get there yet, so we're going to stop right here. Tomorrow we're going to talk about the rest of them. Today I'm going to issue the algebra test again and your trig test. Afternoon, we're going to grade a trig test. If you think you did well, you don't need to come to grade. If you think you did bad, that's where you come to grade. And that's the way I can help you if you did bad. But if you did good, then don't need to come. I don't need to see you. Yes? Probably not. I'm gonna try to finish grading today. Probably 1 hour. This is a lot easier.
I don't think it's terrible now, but do you think I could just get like the ones you're gonna give up? I can like have extra practice.
Yeah, I'm gonna give. I'm post on the group chat too.
You're gonna post it? Okay. I don't know if you're like gonna later tutoring since I'm not able to come out.
No, I'm gonna post a brand new number. I don't want to post the same.
Okay, that's fine.
So that way you can work through, see if you understand those ideas.
Thank you.
But then I also live in Scotland, and like where I live is like pretty busy, so I can just like go back home.
Okay, I have different two sides.
We wanted to have it. The voice version is part of the strength. The student, our students do the thing. I feel like that's weird.
So I solved my math. Jeez.
Girls are saying like in the student for the girls too, like maybe like eat different foods. The coach said no. Well, there's after for the one that you want. There's like yeah, I don't know the difference, but like there's the other foods. There's like I think they were for built in like no, if we didn't get heard like it hits a lot of people, but you only want to
So I've heard it's like
hopefully this year's a lot of food. This year's food like they'll probably say
yeah.
I just didn't want to do super. That's why In snacks, getting snacks. Wait, I know it's one of the students, but I think I was getting here. They're like you. Yeah, but I actually like that. Yeah, so like that was
All right, I'm gonna check attendance. I'm gonna address a couple things. One is this afternoon we're gonna look at a test. I'm gonna grade it through. I'm gonna have most of you guys grade it through. Hopefully we get done today. It's not hard grading. It's actually easy grading. It's much less work compared to last time because it's just trick. Trick is you get it's one page of not a lot of work. So let me arrange new seating because there's people drop out of my class. It's like there's more people drop out of my class than people stay in. Okay, so far everybody's here. Austin, Matthew, where's Matthew? I like Matthew. He didn't drop out, did he? He's here. Ava, you're not gonna be out, right? Ava, you're gonna pull your brother. Okay. Okay. Hold on, I need to answer this call because I think somebody trying to install my dishwasher. They're trying to call me to install my dishwasher. I usually don't answer the call, sorry. Hello, you call me? What'd you say?
Is this Don?
Yes.
Hi, Don. I am Daniel Roland. I'm calling with Client Consent Company. How are you?
Oh. It's not install my dishwasher, so it doesn't matter.
Wait, mister, you use a dishwasher? You don't hand wash it?
No. I'm a lazy Asian, sorry. It's not like the episode you watch from like Fresh Out of Boat. Like
I love that show.
you love that show. They have a dishwasher just hanging there and they're not using it. The mom says it's a drying rack. Because it uses electricity. So those of you guys after school. Those of you guys after school. And we're gonna grade through trade. Just go through and see which question you got. No. If this will be okay for you, but if not, but does it will work? So you just go, just pick any question you know. It's okay. There's no penalty. Not gonna get back grade.
That's all.
Yeah, no, he has a really bad teacher last year. So.
He wasn't a math. He was
What'd you say, Maya? Yeah. He's terrible. My best friend's oh, I don't have best friend. I have more ops than friends in this school. Every single teacher is my ops.
No, I read it like one.
They hate you because they hate you. Don't worry about it.
They hate me because I'm better.
Like if you read it, you need to use your phone.
Like he doesn't make things just like me.
That's okay.
All right.
Oh, then.
That's like
For rest of you guys, just let you know that the first chapter is fairly easy. You know, it's actually a little bit easier compared to the algebra test. But the first test still kind of is very important. So we just start calculus. Before that, it's all like review of your basic foundation stuff like that. I'm gonna issue one algebra test and one trig test, a different version of it. So I usually create multiple version. So I'm gonna issue to you so you can work through it to like understand if you understand this topic or not this topic. You still have to understand those. If you understand those algebra concepts, guess what? It will help you on SAT. It will help you on different situations. So for me, like that's gonna be part of the things I might be able to give you extra credit if you turn it in on Monday. Okay, so if you go through it, like you try to understand every single question, make sure you look it up and things like that nature. With that being said, this afternoon also has a grading, just grading through tricks. Ideally I just want to finish today, so people probably had to grade multiple paper, probably 2 or 3, just in order to finish it. But this grading is a lot easier. It's not like so much work because everything is pretty much one answer. So it's just like, but I'm gonna teach you how to do it. So let's talk about today's stuff. So we're gonna start with today. Last year, I'm gonna start asking questions. How many of you guys have learned the idea of limits? Oh. Limits. How many of you guys learned limits? And can you tell me anything about limits? Okay, let's start with Ember. I thought you raised your hand. You want to say that?
Well, I was just saying, I remember, right? Okay, so limit is like, oh my gosh, if there's like a function, and they ask you like what the limit is, you'll say like, limit f of x equals, hold on, oh my gosh, it's like x to negative infinity, and then x to positive infinity, just like write down like the limit of like where it starts and where it ends.
Okay, that's fine. Anybody else? Yes, Austin.
Well, it's
Okay. Yeah.
Like where a graph approaches and the direction it goes to.
Okay, I like that. Yes. Anybody else? Maya, what do you have computer? Edison? Where's your paper? Anybody else about limits? What do you learn, Peter?
Oh, I'm gonna say like as x or y approaches certain like value, it shows like what. Okay, it's x goes towards this direction. What will y go towards?
Okay. Are you talking about end behavior?
Yeah.
Okay. Anybody else? Maya.
Yeah, I just remember it being like when you write like limit or like x to like infinity, and then like either like near negative infinity or like one, or like there was like limit and then like x to like one with like a positive sign.
Okay, Laura.
Aren't there like asymptotes that even
Good. Good. Okay. Yes. Emma, you want to add something?
so like if you limit as x approaches negative infinity, it would say like how the behavior of the function f of x, and then you just do the same thing for positive infinity.
Okay. So the limits approach that you guys have idea is just about what happened when x approaches infinity. What would a function is either you go up or go down. So either go to positive infinity or negative infinity. That's the idea. Good. Okay, so that's fine. But today we're gonna kind of teach you a little bit differently, right? So we're gonna start with limits. Again, calculus is gonna start with the first thing. So calculus, you're gonna start with the limits. So limit, you have some type of idea from pre-calculus. And then we're gonna go to the next step is the derivative, which is the main part of the calculus. And we're gonna end with antiderivative. You probably hear the word integral before. It's also another word for antiderivative. So we start with limits, we go to direct derivative, and we go to antiderivative. Now, limits. What is limits? Leah said best probably says something x approach something. A lot of you guys says x approach infinity, but doesn't have to be infinity. It could be any value, any x value. So that's what we're gonna start with. What happened when limit x approach something? Now we're gonna introduce the limits. So we're gonna start with a question. And this question is going to be like this. So it says f of x equal to x cubed minus 1 over x minus 1. X cubed minus 1 over x minus 1. Without using graphing calculator, can anybody tell me what this graph look like? The right side goes up. Okay. Ember.
There's a vertical or horizontal asymptote at x equals 1.
Okay, possibly. Okay, Aria.
Degree would be so it would go the opposite direction.
Okay. You're thinking polynomial? Yes.
The exponential function going up on the right.
Okay. Anybody else? Austin? No? Peter? No? You're afraid of being wrong, Peter? That's the worst answer I can hear. You should not be afraid of being wrong. That's what happened with Asian people. They're always afraid of being wrong because they want to perceive like they know this stuff, but they're not. Yeah, you have to be not afraid. Don't be afraid. If I would ask you to give me an opinion, you gotta give me an opinion. Don't be shy. What do you think, Peter? Give it a try again.
Bottom is the
Okay. Austin?
Zero volts.
Possibly. I don't know. It's possible. Everything is a possibility. I just want you guys to think. I don't want you to. I want you to think as much as think you can, because a lot of you guys are learn to be afraid of a teacher. You're afraid to say something wrong, but I don't want you to be afraid of me. I want you to be try to think what it's supposed to be. Right, Gia, what do you think?
There's an asymptote, there's a horizontal asymptote because the x cubed is bigger than the x.
Well, possibly, but I don't think in this case has a horizontal asymptote, but we're gonna get there. But it's a good wording. Edison?
Would there be a hole at x equals 1?
Okay, so both Edison and Austin have something in common. Think about a hole, but Edison think about the whole location, which is good too. So those are the things that you should think. Like I don't want to tell people says you should be afraid of thinking. Like it's okay to being wrong, but it's not okay being wrong and not fix it. It is okay to being wrong. If you today you say Earth is flat, and some people told you says no, the Earth is flat, and you change your view on things, and it's been proving the Earth is no longer flat, then you accept it, then it's okay. But critical thinking is so important. Like every time I turn on the reel these days, I see some people like speaking something, it doesn't make sense. That's something that they would say. Because I start thinking, is it possible if this person says this? Right? And you know how AI can mimic people's voice now. So you don't know what is out there is true. So if you don't critical think things, and if you don't think about those things, you're not gonna be able to be doing really well. So I need a volunteer to come up here. Okay, sure. Thanks, Maya. Okay, we're gonna sit on that song.
Okay.
So let's just say we have a.
Okay.
Let's just say that between us we have a black hole right in the center here. And this black hole is so small, like if you step on it, you're gonna die, but you want to prevent people to step on it, right? So the idea is how you get there, right? How do you find a location of black hole? So we can take a GPS and we say, okay, well, I'm gonna ask Maya, are you on the edge of the black hole yet? Oh, by the way, if anything, I would like to die that way to jump in the black hole. I think that would be a fun way to die. It's that'll be an interesting way to die, right? Probably painless. Will probably be very painful for a short second. You're like, and the screen just vanished. And it's like, break to pieces, break to atoms. I think that's a beautiful way to die. I think that instead of put people in like coffin, they should throw people in black hole. I think that'd be much more better and environmental friendly. So, but yeah, so if we try to find this black hole, and this black hole is really small dot right between all the tiles, so where the cross the tile is, and we said, hey, we gotta find this black hole, and so we're gonna say, okay, well, what we're gonna do is we're gonna start approaching both ends. We're gonna start approaching, and we're gonna take one step closer. So me and Maya are gonna take one step closer, and then by one tile. So we're gonna say, oh, okay, well, we are not in the black hole yet. Right, so we're gonna do the same thing. How many of you guys have siblings?
Oh, wow.
Do your brother ever do to you says, I'm not touching you, I'm not touching you, I'm not touching you? He seems like a person would do that. Really? And then you smack him?
Yeah, actually,
I can totally see that. Okay, so that's the idea. You want to get to this thing. You want to say, okay, I'm going to get closer. So let's take one step here. And so we don't know what it is yet. So we get a location. We say, it's okay, we're coming from both ends. We still haven't reached black hole yet. So we're going to reach one step closer. So this get into the middle. So we're gonna get closer and closer and closer. So the idea is we're gonna reach from both ends, but keyword, both ends. It has to be me and Maya work together to find out the location of this black hole. We can say this black hole is probably like 2, but she's gonna come in from the 2 from the left and 2 from the right. And we're gonna eventually get closer and closer. Does that make sense? So if we get closer, imagine that we can get closer because it won't be legal if I touch her. So like if we get closer and closer, so then we can find out, okay, this is the location. Does that make sense? But we have to approach from both ends. If it's just one end's not enough. But just like without Maya, so Maya have to see, without Maya, if I just say I'm approaching this side, right? And we say we want to find out the center of the black hole, and we come out to this side, but the problem is we're going to reach the edge of the black hole. We don't know where the center of the black hole because we don't have the average between 2 values. Right? So if she's coming from the other side, so one side's 1 and one side's 3, we can take 1 plus 3 divided by 2, and we can say that black hole probably going to be at 2. Does that make sense? So you reach from both ends. The keyword is both ends. Okay. So now we're going to get to that. We said, okay, how do I do that? Let's talk about calculus. How many approach they are, right? So first of all, the calculus has a full perspective. I want you to know. A lot of people are very good with certain perspective. So is perspective. And you should always consider those perspective. So first of all, first perspective is called numerically. So you can approach numerically. Second, you can approach graphically. Third, you can approach algebraically, which is everybody's favorite because everybody just seems like they can do algebra, right? Fourth, now this one's really hard. Now, not everybody can reach this part. Analytically. Now, that's why I asked you, what would this graph look like without a graphing calculator? And that's analytically. Okay, some people say it's this, some people say that. Yeah, there's whole, there's asymptote, there's whatever, there's horizontal asymptote, vertical asymptote, one place going up, one place going down. But analytical thinking skill is probably the hardest thing to acquire. You guys can always do numerically, graphically, algebraic throughout a year, but analytically, it's so hard to do. Not everybody can do it. And can you get a 5 without it? Yes, possibly, but not everybody can do it. And that's okay. But you're gonna try. Every day you're gonna try a new thing. Okay, are you okay there?
Yeah, I can't give up.
Oh, okay. All right. So yeah, so that's their first 2 tests, and that's the prerequisite for this class. So it's kind of difficult, but that's okay. I will switch to AP Pre-Cal. It's still college credit. Are you senior or junior? Senior. And that would be a good class to take, and it will still look strong on your resume. So, and if you have your 7th period open, you know, you can switch to my 7th period if you like me as a teacher. I'm really hard. I'm harder than the other 2. So if you want an easy teacher, probably Kench will be easiest one, I think. Ollie is between me and Kench. So I'm the hardest one, but I'm the funniest one. But I'm also the meanest one too. So I only teach a 7th period, but that's okay. But while you're here, you can enjoy calculus for the first day. This is really easy lesson. You don't have to understand math to understand this part. So the problem is numerically, graphically, algebraically, analytically, you have to think all 4 things. So a lot of you guys can only think about numerically and graphically. It's fine. Algebraically, you had to be able to do in this class. So basically, score AP exam score of 3 points, most of 3 points from algebraically. And to reach 4 and 5, you gotta reach that analytical thinking skill, how to break things down. Now, what would this graph look like? X cubed minus 1 over x minus 1. Most of you guys says there's a hole. There is some type of M behavior. They are all true. First of all, let's figure out what a domain is. What will be the domain of these functions? Do you guys know what a domain? Okay, so what will be a domain of this function? Yep. So first, Amara says negative infinity to positive infinity. Most of the cases are like that. But in this case, the denominator cannot equal to 0. If denominator equal to 0, then something number over 0 is undefined. So it's going to be 1 and union from 1 to infinity. Is that okay? So that's going to be like this. And that's how you find domain. Because you set denominator cannot equal to 0. So x minus 1 cannot equal to 0. X cannot equal to 1. Because when the x equal to 1, it's going to be 0 on the denominator. 0 on the denominator is bad. But in this case, what happens if you plug in 1? What happens if you plug in 1? What is f of 1? Is 1 cubed minus 1 over 1 minus 1 is what? It's not 0. It's 0 over 0. And 0 over 0 in calculus, we don't count it undefined. We count it indeterminate. If you ever get 0 over 0. It's not undefined. It's indeterminate. Besides that it's indeterminate, you're going to say, okay, well, if indeterminate, then what would be this question's mainly look at? The mainly look at is I want to look at what happened when they're indeterminate. What will be the happening over there? Now, Edison and Austin says there's a hole. And I think Leah or somebody else says there's asymptote. Some people says it could be an M behavior going up. So we don't know what is it, but I'm going to show you on the graphing calculator. So we're going to look at the graphically approach right now. We're going to look at this function. We're going to say x cubed minus 1 over x minus 1. Wait, why do they look like a parabola? Can somebody tell me why they look like a parabola? Yes, Gia.
Because if it's x cubed divided by x, then x. So parabola only has goes up the same direction.
I'm trying to think about, I'm trying to disprove that. I don't know yet. I'm trying to disprove that, whether that's always true. Possibly, yes, Austin.
The new factor, like a cubic expression that or that first that first a minus b term is gonna be x minus 1 and they cancel each other out, so it's just gonna be quadratic.
Yes, that is exactly the reason. Leah, what are you gonna add?
Oh, I was gonna add on to Gia. I was gonna say, like, to your disproving, wouldn't you like shortcut in if you did that, like if you crossed it out?
Yes, you cannot cross out as x. You cannot cross out as x. You can, yeah, mathematically, you cannot just kill a kitten. Yes. But what you can do is factor the top. Use the SOAP to factor it. So if you factor the top, this is what you get. Okay, so now I want you to pay attention when they. Do you see anything abnormal here? Anything? No? Yes? Maybe?
One comma 3.
1 comma 3. You see this is undefined.
Yeah.
So this is called a hole, right? So the thing is, there is a hole at a value. So we just look at a graphic approach. We take a look at it. We says, oh, graphic approach. It looks like it reached at 3. But we also gonna talk about numerical approach because hey, let's do a numerical approach. And how do we approach it? Well, we're gonna approach in 1. So we're gonna approach it like how me and Maya approach it. We're gonna approach at 1. We're gonna 1 coming from the left side. What's a value that's very close to the left? To 1. But from the left side. 0.5. Okay, let's start with 0.5. But here's how you're gonna do it. So you're gonna get a phone out and you're gonna open up the decimals. I'm not taking away your phone, don't worry. I like to break school rules. But I want you to learn how to use decimals because some of you guys taking SAT, decimals is the only calculator you have. And once you type in a function, I want you to click the wheel on the top. Do you see that wheel says edit list right here? And you're going to click on it. And that table is going to show up. You're going to click on the table. Is that okay? Now, once you click on the table, we're going to plug in values. We're going to do a numerical approach. That means we're going to plug in random number until we get it. So that's going to be, we want to approach 1. What's a value that's close to 1? 0.9. Okay. She says 0.5, but we're going to approach it a little bit closer than that. We're going to approach 0.9, right? Is there any way I can approach even closer by 10 folds? 0.99, good. Then we're going to say 0.99, right? 0.99. So you see that it went from 2.7 to 2.97. You see the output. And 0.999, right? And we can even do more. We can say 0.9999. And eventually you see if I click 1, it's undefined. And if I do 1.0001, still 4 digit, 1.001, 1.01, and 1.1. Now you see that they come in for this value from both ends. If you come in from both ends, when they reach 1, it's undefined. It's not really defined in this moment.
Where does the 3 come from? The exponent?
Where's the 3?
On the y-axis. 1 comma 3 is undefined?
1 comma 3 is undefined, yes.
When you get the 3 if you were solving it analytically.
Yeah, so what happened? We just do a numerical approach. We don't know is 0 over 0. If we're doing algebra, we find out 0 over 0. But we can say we can plug in numbers really, really close. So like me and Maya is gonna, because we cannot step on a black hole. We step on a black, we take a GPS, we stack on a black hole, we don't know what a GPS reading is, right? Because we die. So what if we just stand on getting closer? We're gonna get very, very close on both sides. So Maya's side is gonna reach 2.9997. For my side, from the positive side, is 3.003. So we can say the average of those two is roughly at 3.
Okay.
Yeah, so when you get there, it's undefined. So that's a black hole. You die. Doesn't matter you hold a GPS, you're not gonna get a reading. Okay. So any questions? So we done numerical approach, we done graphic approach. We didn't do algebraic approach yet. We didn't do analytical approach yet. But right now, today, we just need to focus on those 2 things. So right now, I'm going to ask you to use decimals and to figure out what happened with this function. F of x equal to x over square root of x plus 1 minus 1. And not only that, I want you to figure out domain if you can. Figure out a domain of the function. Okay, it's kind of hard, but I want you to see if you guys can figure out. Also, I want you to figure out what happened limits as x approach 0. You can use decimals with this one. X plus 1 minus 1. What happened when you approach 0? So first, you find the domain of a function. Second, you're gonna use a numerical approach. You can use decimals to figure out what happened when x approaches 0. Try the numerical approach. Or then look at the graph. Now the hard part is finding domain. If you don't know how to do it algebraically, you can do it from graphing calculator. All right, what'd you guys get? Start with when limit x approaches 0, what'd you get? Austin? Okay, can you tell me the domain?
-1 to 0.
Okay. Do you look at a graph or you do it algebraically? Good. How do you do it algebraically first? You said denominator equal to 0, so okay, good. So domain denominator equal to 0, that's good. X plus 1 minus 1 equal to 0. So x plus 1 is because denominator equal to 0 is undefined, right? 1. Square both sides, x plus 1 equal to 1, x equal to 0. So x cannot equal to 0. And there's one more place. What else? Y is a -1.
When you have -1, you plug in for x. You get square root of 0 and square root of 0 to 0. So you still get a value for the denominator. But if you use any other negative value, it becomes undefined because you can't take the square root of a negative.
Right. So take the denominator set equal to 0. That's the first part, is undefined. Second part is take inside the square root, but greater or equal to 0. Why is that? Is x greater than -1? Because when x is less than 1, you're going to square root a negative number. It's undefined. So square root of a negative number is undefined. So there's no point. So therefore, it's going to be a number line. It's going to look like this at -1. It's going to be a solid dot going here. At 0, it's going to be an open circle. So therefore, it's -1 bracket 0 and then 0 to infinity union. So that is the domain of the function because you said denominator equal to 0 because denominator equal to 0 is undefined. Also, you said radical is greater than 0. that is when the real number can exist. Yes.
Can you explain the x plus 1? To find the negative 1 from the domain, why are you using what's in the square root?
Because if you think about it, what happens if you do what Austin says, right? Square root of 1 is fine. Square root of 0 is fine. Square root of negative 1 is what? Imaginary. So it's not real. So you're not going to see on the graphing. So you set x plus 1 greater than 0. That's why you cannot equal a negative number. If you have square root of a negative number, it's not going to define. That's why the graph, if you graph in graphing calculator, there's nothing on the left side of negative 1. Yes, dear.
I understand like the procedures, but how did you know like how to go from blue to the green?
Oh, so this part?
No, like you put x equals to 0, and then you set like the inequality equation.
Okay, so this is two separate parts. So this part is for the denominator. This part is for the radical. So this is a radical. So radicand has to be greater than or equal to 0 because you don't want a radical of negative number. Okay, now we're gonna do it approach numerically, right? So if I approach numerically, it's x divided by root x plus 1 and minus 1, I think. It looks, wait.
It has to.
You press the right.
Yeah, so the graph didn't have anything other than negative 1 side, right? It's only have positive sign. Now I'm gonna click on this wheel. I'm gonna plug in a table. I'm gonna say 0 0.9, 0 0.99, 0 0.999, right? Oh no, sorry, it's not 0 0.99. I'm sorry, I did it wrong. 0 0.01. So 0 0.1, 0 0.01, because I approached 0 from the left, from the positive side. 2 0. So it's approaching 2.0005. How about the negative side? Negative side is going to be negative 0 0.0001. It's too much zeros. Negative 0 0.01. Like this. Negative 0 0.01. Negative 0 0.1. Do you see that it's approaching 2? Right, as the value go into 0, this is going to be 2. And if you zoom in enough, right? If you zoom in enough, let's just say here, graphically approach, that's going to give you a open circle as well. And that's how you do it graphically, and that's how you understand how that is. With that being said, does that make sense? Yes. For this part? First part, I'm just say this part, he says cannot equal to 0, right? So it's going to be open circle for sure, because that's where the vertical aspect. This is the cannot denominator equal to 0. So what happened? You set the denominator equal to 0, and you find out what that cannot equal to. Actually, this should be cannot equal to if you really want to be picky. That x cannot equal to 0, because denominator equal to 0 isn't defined. Now, what you're gonna do is take inside a radical, set it greater than or equal to 0, because you can have radical of negative number. You can only have radical of positive number. You can radical of 0, by the way, but you cannot radical of negative 1. Does that make sense? Okay. Now we're gonna talk about the next graph. This one is done. We know that's equal to 2 numerically is I using the calculator, right? Using decimals. Now I want you to put your phone away and I want you to look at this graph. Now this is a time that I'm going to challenge you to think analytically. So that's why I'm going to say is don't use graphing calculator. What would be this graph look like? Absolute value x over x. What would this graph look like? So without calculator, can you tell me, think a little bit more. Hold on. I'll think a little bit more. What will this graph of absolute value x over x graph look like? And it's okay to have a wrong answer. I think a lot of you guys are afraid of being wrong. You cannot be afraid of being wrong. If you're afraid of being wrong, you never get it right. So I don't mind you have a wrong answer. I think wrong answer is fine. But if you don't know how to fix your wrong answer, that's not okay. Anybody think that what a graph look like? Absolute value x over x, raise your hand. Amara?
Must be 1.
1?
Value of x would be x and then x over x.
So what does a wine graph look like? Go through origin? Okay. Ethan?
Straight line going left to right, and then when it gets to 0, what would it be? -1 on the left side, +1 on the right.
Okay. Austin?
When you do like on the negative side, like a straight line, and there can be a value because 0 to 0 is indeterminate. On the positive side, it'd just be a straight line over 1.
Okay, that's what Ethan says. Good job. Anybody else? Anybody else want to ask something? Yes, okay. Okay. Anybody else? Yes, Leah?
I was thinking about something with like mirroring.
Okay.
It's like absolute.
Okay. That's fine. Anybody else? So we don't know what a graph looks like. Now I'm going to show you. Let's see who is right. First of all, I want to introduce you a new idea. And we're going to talk about what ds is. ds is absolute value of x is equal to like this. Right? It looks like this, right? It looks like V shape. And my next challenge is, can you come up another expressions, another way to come up look like this graph? Okay, to come up look like this graph. Does anybody knows like what's another way to look at this? That another expression is going to give you the exact same graph.
Is it like what we just did? Or what?
Okay. So this period I'm kind of late. Okay. Look at this. Root x squared. Root x squared. Root x squared. Okay? That's look like exactly the same things as well. Again, this is what you need to know. So what we're gonna do is we're gonna understand this part. So so root x over x. So what happened is you got this. And you say, well, okay, remind me to start right here. So just say we're gonna talk about absolute value x over x graph. And you have no homework, but your homework is gonna be the test. If you wanna do a better job on the test, I know some people said, I wanna say here, but I won't look at that.
And as a reminder, we do have Kelly's ice cream here for you all, so teachers and staff.
I know. I feel like it's true, but like. Really?
What is it?
I don't think. That's like weird. Okay.
Okay.
Why?
Maybe I'll send it to Parati. So here what you can do is, do you know Parati?
Yeah.
Okay. Send an email to Parati. Chat to him. Just says, I have no processing last year, and I don't have enough knowledge for calc. Is it possible to switch into 83 calc? And that will be a class to go. Now, if you want to take the easy way out, senior year, you want to take it late, you can do college and math readiness. You can also do financial literacy. You can do a lot of other stuff. But calculus is class will be not directly for you because it's not because of you. It's because the teacher you have. I'm pretty sure you're a good kid, but the teacher didn't teach you enough information to study. So email them first, and I will talk to Parati. So give me your full name first.
Okay. Or
No, you are
Micah. M-I.
How many talking? 2K?
C-A-H.
Yeah.
okay. And what's your last name? What?
Chadwick.
What is Micah?
Yeah.
I don't remember.
Okay.
Yeah.
All right. So let me do that. You gotta send email first before I can change.
Okay.
So you gotta send email
Yeah,
to
you good.
Parati and your teacher.
What you going
Your
That's good. Do you only have AP pre-calc though for you?
Yes.
But
But
that was really the
yeah,
Yeah,
that's
yeah.
right. But I don't know. Like that's the only period I don't mind to take people in. But yeah. So that will be the class. That's only one I have because I have all of those calculus. Okay. All right. Cool. That's good. Bye. I'm gonna send a group chat.
Oh, it's all fine. Okay. Thank you.
Oh, can I see my algebra test before I sit down? Oh no, why this? There's no way you had it on the top of your desk. No way. I got an 80.
We did 80, right? That's fine.
Nah, brother. That's 15 points less than last week.
Oh, somebody got dumber.
God damn it.
Everyone, this has been worse than mine.
This shit full of Sean, bro.
Sean, how's Sean Padani doing?
Good. Whatever. But every time someone talks, like, I was like, you should join BC. He's like, nah, I did horrible on the algebra test. I got like 12. I was like, Sean got a 2. Oh,
Where were you yesterday, huh?
I was at home. I thought I tore my
2 days a week.
Hey, it's
That's
senior
too
year.
much. That's too much.
Roger, are you trying to get senior?
Yeah. Bro, I don't even know.
I'll book you.
Where is it? Thank you, bro. Bro, how did I do this?
Oh, no one's here.
It was nice to
1 minute remaining to do it.
Oh my god, it's so much. You're so old. You want to simplify?
No, it's not.
We're actually doing this because what we did I forgot my stuff about
Where's everybody?
a lot of people are staying home because I think
Yeah, it's singing.
Are you freaking kidding me?
we can lose the month. I came today. Yeah, if you took anyone's stay home today, it would have been me, but I came today.
Oh, here's some more people.
Study for SAT? That's an excuse not come to school?
That's what I heard.
You don't even need to study for the SAT.
You should see the English. I've been doing that thing the last 4 days. I'm good at I don't like grammar, bro. Grammar is not makes no sense.
Yeah, that's what
You wanna?
Give me a second. I think about it, but give me a second. Let me check attendance.
My English score is 790. People like 790. What's your English score?
Bro, I'm gonna get a 780.
Are you taking it?
Tomorrow, no. When we take it in school, I'm gonna get
I'm not
it.
gonna.
Wait, Nick,
What'd you get? Right.
Overall, 780, 720. So I need to get my minimum. I'm trying to get like a 750 minimum.
I got 760 on the PSAT.
Yeah. The PSAT I got like a 750.
How am I? I don't. How do you know
Is Lakshmi here?
from PSAT?
Yeah, PSAT. PSAT reading I had a 750.
What's happening?
Aiden's here, right? Wesley, Tanner,
I'm right here.
Vincent.
I think everyone and Lex. Yeah, everyone but Jordan. Lex can drop. Shit. What? Lex can drop the ground. I made a business decision.
Okay, so by the way, Muava data, according to Anthony's, we have to have certain officers and or Beta or Lucia. For us right now, I have and Vincent wanted be the tutoring for the calculus, which is he's really good at tutoring. Yeah, so if you want other positions, talk to Anthony, and I will decide whether is good fit for that situation yet. So
So you have a final say.
yeah,
So like last year we did like what elections, like we voted for them. So I don't know.
yeah, but this year they used to have like the older member. They kind of select like which person is it, which person going to be or whatever. I don't know how that works, but
We're gonna have a meeting after school, like me, Veda, Lucia.
yeah. And if you're interested, come after school, and maybe you can chip in, see what you want to do. But for me, like, I want all the people to join, and also especially BC. I want to look at because we need a lot of help we are gonna host for the first math competition in this school. So I need a lot of people's help, and especially you guys because you guys know the math part.
Do you want AB students to be alcohol? So I don't know how I would contact.
I will contact them through group chat, so I can send out a message. But today just officers. If you're interested about running officers, pretty much I'll just think of like what's good position for you, and we can be there. Yes. But we're gonna use that money for some things. Usually I use the money to buy pizza at the end of the year. But we also need money for competitions. So a lot of you guys are interested in competition. We gotta use that money for competition. And this year, which is last year, we did not do. This year, our priority is to make sure a shirt for everyone and courts. So and Veda and Leah are supposed to be responsible for that. So far as on that part, that's that. If you're interested, come after school. Yes.
How much is it for entry fee? 20. 20.
20 should be enough. I would say probably 25 because
20
we
plus
need a
tax.
shirt.
Oh, hell.
We need a shirt. Okay. That we're gonna go to the last part of limits, and we are not gonna put El Hapto rule on the test. Just because I want a student to do without El Hapto rule, or I will trick you into a certain question that you have to do El Hapto rule, but you end up getting nothing done.
Bro, what?
You're welcome.
No, I'm gonna go with some water.
All right. All right. So oh, I'm streaming for a lot long.
Might be on the test, or no? It will.
What?
Who is that, bro? Bro, please say my name. Love from India.
I have been from India.
No shit. Why